Okay, we're going to talk about radicals and rational exponents today. And first, before we can do that, we need to know some definitions. When we look at a exponent to a fractional power, really, if it's a fraction, you can write that as a radical with an index number. So what you're familiar with mostly is square roots. So let's say you have the square root of 8. A square root really means the second root. It means what number times itself twice makes 8. Okay? So if we were to change that to say like the square root of 4 or the square root of 9, some of those perfect squares, you would know, for instance, square root of 9 is 3 times 3 because 2 3's multiplied together make 9. Well, if we change that, we say like the third root of 9, that's saying what number times itself 3 times makes 9. And really, looking for those numbers, like 9 isn't a perfect cube. The third power means cube. 9 isn't a perfect third root because there isn't a number that multiplies by itself 3 times to make 9. However, we once again, to change this to 8, you could say, well, 2 times 2 times 2 is 8. Therefore, the cubed root of 8 is equal to 2. Okay, and so really that's how we write it as a radical. And we can change that to a power by saying, okay, whatever number index you have there really can be written in this format. So we take the base number, the number inside, the big number, and make that our base over here, our big number here, and then a fraction, we'd have 1 over whatever our index is, whatever number's here. So if we wanted to write the cubed root of 8 as a power, we could say that's 8 to the 1 over, and then we'd use that power 3, 1 over third power, the 1/3 power. And just so that you kind of focus on that a bit, if you kind of look at some of the properties we have, or actually let's look at a pattern here. Let's say we have 2 to the third power, and 2 to the second power, and 2 to the first power, and 2 to the 0 power. Well, when we do that, that 2 to the third is 2 times 2 times 2, okay, which we know is 8. And 2 squared, or 2 to the second, is 2 times 2, which we know is 4. And 2 to the first is just 2, which we know is 2. Okay, and 2 to the 0, well, you start following this pattern. We're dividing by 2. Obviously, there's 1 less 2 here. Okay, so you divide by 2 or cut it in half. So if I keep following that, I cut it in half, this becomes 2 to the 0, which is 1. Okay, which we can explain why anything to the 0 is 1 in this way, but it's really not where I'm going. You know, I go to 2 to the negative first. Well, really, that means I'm dividing by 2 again, which is 1 over 2 to the, or 1 over 2, excuse me, or 1 divided by 2, or 1/2. And 2 to the negative second. Well, if we divide a half by a half, or we cut a half in half, really that's 1/4, right? Well, 4 can be written as, you look here, 4 can be written as 2 to the second power. So really we could change that to 2 to the second power. And actually 2 can be written as 2 to the first power, right? So when we start looking at this, we can kind of start seeing another pattern develop here. Okay, we got 2 to the first, 1 over 2 to the second. So 2 to the third, or 2 to the negative third, is really, divide by 2, that's really 1 over 2 to the third, or 1/8, right? So that's what we have there. Well, in between those numbers, so like in here, you have fractions, right? Between 1 and 2, okay, you have fractions. And between 1 and 0, you have fractions. Okay, so if, for instance, I wanted to deal with 2 to the 1/3 power, well, 2 to the 1/3 power would go right in here somewhere. It's in between, 1/3 is in between 0 and 1, which means 2 to the 1/3 power, if I were to actually calculate it out, would be between the number 2 and the number 1. Right? It's saying, what is the cubed root of 2? That's what that's asking right there. And so when we look at it like that, really you're just kind of filling in some of these gaps in between the powers. That's what we're doing with this lesson. Okay? And so we can kind of fill in those gaps with different fractions. Right now we're dealing with like thirds and halves and fourths, but later in the lesson we're going to be dealing with like 3 halves. So like 1 1/2. So what's in between 1 and 2 and so on. Okay, so let's try some of these. There's some odds and ends we need to take care of. So find the indicated real nth root of A. So really what we're saying here is try to find the nth root of A. Okay, that's what this is asking. And so that means when we look at n is 5. So we're looking for the 5th root of negative 243. Well, that kind of presents a unique situation because we've talked about negatives in the past and negative exponents. Usually we say, hey, when you have like the square root of negative 4, remember square root means what two things multiply together. So like this times this make negative 4. Well, the reality is when we've dealt with square roots in the past, you can't multiply two things that are the same and get a negative, right? I mean, either both of them are going to be positive, and positive times positive is positive, or if they're both negative, negative times negative is also positive, so it's not possible. Okay, however, if we're dealing with a 5th root, well, a 5th root to make a negative, this is saying if we multiply 5 things together to make a negative number, so like 1, 2, 3, 4, and 5. So we're multiplying these 5 same things together to make a negative, right? And we have to make a negative, so if it's going to be negative, we're going to have to at least introduce a negative. We can't multiply all positives and get a negative, so these 5 things would all have to be negatives. Well, notice what happens. 2 negatives make a positive, so negative and negative, this pair of negatives make a positive. This pair of negatives make a positive, but then you have that extra lone negative there, and that's how we get the negative there. So when you're dealing with odd roots, you can have a negative on the inside. If you're dealing with an even root, like a 2, a 4, or a 6, you can't have a negative on the inside. That's a no solution. You can't do that, or no real solutions. Okay? I guess we add the word real because I guess technically it's imaginary. It's a whole other lesson. So the 5th root of negative 243. So we're asking ourselves, what number multiplied by itself 5 times makes negative 243? So one thing you might want to do is, and I'm going to scroll back here, is make a table. Okay, x, and we'll say this is x to the first. I'm sorry, with x is 1, 2, 3, 4, and 5. Okay, and then we'll put x squared. That means we're going to multiply x by itself, and x cubed, x to the third, x to the fourth, and then x to the 5th. Okay, let's say we have all of these, and we kind of stop there. Let's fill out this table. It'll help us out so we can keep track. So x squared, 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 is 1. In fact, 1 times itself doesn't matter how many times, it's always 1. Okay, well, let's try 2. 2 times 2 is 4. Times another 2 is 8. So that means 2 to the third is 8. Times another 2 is 16. So 2 to the fourth is 16. And times another 2 is 32. Okay, 3 times 3 is 9. Times another 3 is 27. Times another 3 is 81. Times another 3 is 243. Okay, and in fact, that's the number we were just looking for. But we'll finish this up here. 4 times 4 is 16. Times another 4 is 64. Times another 4 is, excuse me, 256. And then times another 4. Well, if you're not good at this, 4 250s is 1,000, and 4 6s is 24. That's 1,024. Okay, and then 5. 5 squared is 25, and then 5 to the third, or another 5 here is 125. 5 to the fourth, by the way, is just, when you're multiplying x to the fourth, it's just x squared times x squared. All right, power of properties here, we just add those together. There, we got it. Power of properties. So So I could multiply x squared by x squared, which is 25 times 25, which is actually 625. And then the last one, if you're not familiar with it, 5 times 6 is 30, so 5 times 600 is 3,000, and then 5 25s is 125, so that's 3,125. Okay, so I was looking for the fifth root of negative 243. Well, the fifth root of 243 is 3. So when I go back to this, that would mean the fifth root of negative 243 is negative 3. In fact, if I want to do the fifth root, which is this next problem down here, of 243, it's 3, positive 3. How about the fifth root of 0? The fifth root of 0, in fact, any root of 0 is 0. Okay? Well, notice roots with an odd index, so 5, 5, 5, in fact, 3, 1, we usually don't do the first root, but 7. Roots with an odd index will have one real root. Okay, key statement there. Let's try some even indexes over here. So like the fourth root. Let's do the fourth root of 625. What number multiplied by itself 4 times makes 625? And so if I back up here, well, fourth root, 625 is here, that is 5. Okay. We've got 5. Now notice 5, so remember I'm multiplying 4 things together to make 625. And we've determined it's 5. So 5 times 5 times 5 times 5 is 625. Positive times positive times positive times positive is positive. Oh, my apologies there. Okay. This last one is positive, right? Okay, well, also note that if I wanted to multiply 4 negatives together, remember, pairs of negatives make a positive. That's a positive, and that's a positive. So really, negative 5 times negative 5 times negative 5 times negative 5 also makes 625. So our answer has to be positive and negative 5, and the way we write that is plus minus 5 like that. Okay? Let's do the fourth root of negative 625. So the fourth root of negative 625, so we're trying to find 4 numbers that multiply together to make a negative. So we have positive times positive times positive times positive can't make a negative. Negative times negative times negative times negative. Remember, each pair makes a positive, so that won't work either. You can't take an even root of a negative. You get no real solutions. And the last one, the fourth root of 0. Well, the fourth root of 0, any root of 0 is 0. So roots with an even index, we'll notice, could have up to, well, we have 2 solutions here. We have 1 or no solutions here and 1 solution here, because they could have up to 2 real solutions. All right, so let's try some of these together. To do the third root of negative 64, so what number multiplied by itself 3 times makes negative 64? Okay, we could also think of that as negative 64 to the 1/3 power. Notice I put it in parentheses because you're raising negative 64 to the 1/3 power, and that would mean negative 4, because negative 4 times negative 4 times negative 4 makes negative 64. And note the difference here in the way this one looks. This actually says, well, we're doing 64 to the 1/3 power, but the negative's on the outside. Well, 64 to the 1/3 we do first, and that's 4. And then we bring down the negative. And I know that it doesn't look, the answer is identical, but it's a big deal. Those parentheses will matter, especially when you're dealing with positive exponents. Okay? Let's take a look at it here. 64 to the 1/6 power, okay, which means actually the 6th root of 64. So what number times itself 6 times makes 64? 2, 2, 2, 2, 2, 2. So we'll test those out. That's 4. That's 4. And that's 4. And 4 times 4 is 16 times another 4. Oops. Oh, that's 64. So the answer is 2. Notice I didn't put plus or minus 2. And the reason I didn't put plus or minus 2, remember this problem right here? We had to write out the problem and put the radical symbol. Okay? Whereas in this problem, it was already written out in exponent form. So there's a thing called the principal square root. And that just means if they write it out in exponential or in radical form, and they don't put plus and minus in front of it, it's just positive. It's looking for the principal. They just want the positive answer. Okay? Well, this one says the sixth root of negative 64. So what number times itself 6 times negative? And remember, you cannot take the root, a negative root, or an even root of a negative number. This is no real solution. All right. Well, let's go ahead. Remember, we just talked about these gaps right here in between like 1 and 0. Let's talk about the gaps between like 1 and 2 and 3 and 2, and so on. So where those come from is when a to the 1 over n is raised to the power of m. So we now have like a to the 1 over n to the mth power. And we write that like this. We can write a to the 1 over n as the nth root of a. So remember, that would be like saying, hey, we have, let's actually put some numbers to that. Let's say let's use 8 again. 8 to the 1 fourth power. Okay, that would be written as the 4th root of 8. And then we're going to raise that to a power, say like third. So third. So here we're saying n is 4 and m is 3. Okay, so that's how that transforms. But another way you can actually look at that is like so. We use that 8 to the 1/4 to the third. We could use our power, our properties of powers, or property of exponents, and multiply that in. And so when you're doing that, really that's saying you have, if we just deal with a fraction, that's 1 over n times m over 1, which is 1 times m, or m over n, right? And so we could write it as a to the m over n. And one way to see that, the numerator is actually the inside power, and the denominator is the index. Okay, and so a lot of times you'll see it in this format. So using our example up there, if we were using 8 to the 1/4 to the third power, we could actually write that as 8 to the, bring that 3 in, so it would be 3/4 power, which would equal, if we wanted to write it like that, the 4th root goes right here. The 4th root of 8 to the third. Okay. A lot of textbooks will write it like so. The textbook we use uses this format primarily. Okay, and another example there, just really quick. 8 to the 2/3, another way of saying it. Okay, just so we're clear. The denominator goes on the outside, the numerator goes on the inside. We could also write that as the cubed root of 8 all squared. Okay, so let's try some problems with that. In fact, this one right here, evaluate each expression without using the calculator. This saying the cubed root, right, that's our denominator, of negative 8 all squared. Now you could either square the 8 first or take the cubed root, and it's usually easier to take the root because it makes a smaller number. So the cubed root of negative 8, what number multiplies by itself 3 times to make negative 8? That would be negative 2. And negative 2 to the second is positive 4. Oh. one, a little more complex. This one is saying the fourth root of 81 to the third. Except for that third is, or this radical is negative. And remember what a negative exponent means. It means we actually have to take whatever we have and change it to the other side of the fraction. And that makes that exponent positive. So really, this thing that I just wrote is going to stay, but it's going to be in the denominator. So we would actually write that as 1 over 81 to the negative 3/4, which would mean 1 over the fourth root of 81 cubed. But I don't want the fraction to become such an issue, so if you just evaluate this part and then remember it's on the bottom, that helps out as well. But let's take the fourth root of 81. Something that multiplies by itself 4 times to make 81. Well, that is 3. So we have 1 over 3 to the third. And 1 over 3 to the third, well, 3 to the third is 27. So this becomes 1 over 27. Evaluate means get it down as far as you can there. Okay, let's separate these with some lines here. Okay. 4 to the 7 halves, well, I'm going to go ahead and write that out. Oops, I did not mean to do that. Sorry. So that's going to be equal to the square root of 4 all to the 7th. Notice you could write the square root like that, or you could just not include the 2. Okay, square root of 4 is 2. And 2 that is not squared, I'm sorry, that should be to the 7th power. 2 to the 7th. I like to use my fingers to count it. 2, 4, 8, 16, 32, 64. Okay, well, 128, that's 7 of them. So 2 to the 7th is 128. And notice I didn't have to put plus minus because there wasn't a plus minus in front. That's only if you have to write it out in this format, or in this format, it wasn't given to you that way. Okay, so 128. 8 to the 4 halves root. The reason I put this problem on here, because if you write out, and if you're taking notes, you may not want to do this. You'll be frustrated here in a minute. If I do the square root of 8 to the 4th, well, the square root of 8 is tough. It's a decimal. And then I multiply to the 4th root, or I'm sorry, raise it to the 4th power. And some of you would be able to do that. You look at it and go, okay, well, that's root 8 by root 8 by root 8 by root 8, which is true. And if you're familiar, root 8 by root 8 is root 64, and root 64 is 8. So anytime you multiply a root by itself, you get the thing inside. So the 8 just drops down. And here you get 8 as well. And 8 times 8 is, 64. So the answer is 64. However, an easier way to do this is to just think of it like this. 8 to the 4 halves, reduce the fraction first. That reduces to 2. So really this is saying, what is 8 to the 2nd? And we know that as 64. So always reduce the fraction first if you can. I don't want that to look like a 9. But all right, and the last one here, this is saying the 10th root of 1 to the 9th. Well, what number multiplies by itself 10 times to make 1? That is 1. And then when I multiply 1 by itself 9 times, what do I get? I get 1. Okay, all right. Well, I think that's it. Yep, good luck.